For this first tutorial, a heat exchanger will work on the sizing of a heat recovery heat exchanger. So in that case, we have one hot fluid. This fluid consists in flue gases. So the inlet temperature of this hot fluid is 135 degrees. So we can imagine that there's a machine using combustion and doing we don't know what, maybe a motor, and we want to recover some heat from these flue gases in order to use it for something else, for example for heating one place. So we have this hot source resource from which we want to take some heat, and the mass flow rate of flue gas we have is 50 kilograms per hour. Then the heat recovery heat exchanger that we are going to size is a cross flux heat exchanger. So it means that the other fluid, which is water, in our case the cold fluid, will have flow in the direction perpendicular to the flow of the flue gases. So it is schematically represented this way, but it's not properly represented, because you need to imagine that the different turns of the water pipe are all in one plane that is perpendicular to the flow of flue gases. It changes a bit something because we don't consider any influence of the flow that has been cooled by one tube over the heat transfer on the following tube. So we consider that all the turns are in the same plane for the water. The water, so that's the cold fluid, has an inlet of 10 degrees, and we already know which kind of pipe we want to use. So we know the thermal conductivity is 10 watts per meter Kelvin. For this conductivity, we can guess that it's probably stainless steel. Anyway, if we exchange heat with the flue gas, that's the kind of metal we would like to use. We know the inner diameter of this pipe will be 2 centimeters and outer diameter 3 centimeters. So we cannot neglect the thickness of the pipe, as it is sometimes the case for heat exchangers. So that's the first data we have, and then in order to do the sizing, we will set some objectives. So we want to heat up the inlet water up to 50 degrees. So we will try to find what mass flow rate of water is needed. We also want to cool down the hot gas down to 20 degrees in order to recover as much heat as possible. And in order also to do the sizing, we don't only have the mass flow rate of flue gas, but also the velocity of 1 meter per second. So based on this example, we'll try to first calculate how much heat flux is exchanged between the fluids, then this mass flow rate, and then we can start the sizing. The big question of the sizing will be how much surface we need for the heat exchange between the two fluids. In other words, how long needs this pipe to be. So that's the exercise.